In section 4.2, we're going to talk about congruence, and namely how it refers to polygons, and the focus of this chapter is on triangles. So after this section, we'll mostly be talking about congruence of triangles, but we will talk about congruence of other types of figures like quadrilaterals and all those things as well. We say two figures are congruent if they have the same size and same shape. Okay? They're exactly the same shape and exactly the same size. All right? They look alike. Okay? Everything about them matches up. Now, something we have when we have congruent figures is called corresponding parts. Corresponding parts. Now, corresponding parts refer to sides and angles. Right? All of our polygons have sides and angles. Triangles, we know, have 3 sides and 3 angles. Quadrilaterals, 4 sides and 4 angles. All that good stuff. So when we have some that are congruent, they have corresponding pieces. So, for example, let's say we have triangle JKL is congruent to triangle TSR. Y'all, the names of triangles are important. The order in which things are written is important. All right? So, the names of writing congruent triangles is written so that corresponding pieces line up. So what we're going to do first is talk about all the parts of these 2 triangles. Now, they didn't even give us a picture. They just told me triangle JKL is congruent to triangle TSR. All right? So we can use the names and the way it's written to tell which parts are congruent to which parts. All right? So, for this triangle, triangles have how many angles? 3. Now, the good thing about how they're written is angle J is in the same spot as angle T. Y'all see that? Those are the corresponding pieces. So angle J is going to be congruent to angle T. So they're written in the same spot. All right? So angle J is congruent to angle T. So whatever is written in its same spot is what its corresponding part is. Does that make sense? That's it. So, which angle do you think is congruent to angle K? Angle S. It's written in the same spot. Does that make sense? And lastly, angle L is congruent to which one? Angle R. Does that make sense? The first ones are congruent, the middle ones are congruent, and the last ones are congruent. They also have congruent side lengths, congruent sides, and they are written oriented the same way too. Segment JK is congruent to what segment do you think? TS. All right? And then you got, put the last 2 together. KL is congruent to which segment do you think? SR. And then the first and the last goes with the first and the last. So segment JL is congruent to segment what? TR. Does that make sense? So I'll show you the little finger dance without my red marking everywhere. For the segments, this 2 is congruent to this 2, these 2 to this 2, and then first and last. Right? And angles exactly match up. Okay? So the name, this congruent statement is what we call it, a congruent statement of congruency. Okay, that's what we call that. Is very important. The order in which you write the letters matters. Okay, you have to write them so that the corresponding parts match up in the same spot, because that means those angle measures are the same. All right, open your book. Nope, sorry, wrong thing. All right, so we're going to use that to help us solve for x and y in this problem. Now, what kind of polygons are these? Quadrilaterals. We don't know that they're trapezoid yet. One thing I haven't taught y'all about trapezoids yet. They look like trapezoids, but they're quadrilaterals because all we know about them for sure is that they have 4 sides, right? All right. Well, the reason we can't say they're not trapezoids is because we don't know that those lines are parallel. Because that's what a trapezoid is. I haven't taught you about those yet. All right. So they're quadrilaterals because they got 4 sides, right? Now here's our congruency statement for quadrilaterals. Quadrilaterals don't have a special little symbol. Okay, they just don't. Squares do, rectangles do, triangles do, but quadrilaterals don't. But it still matches up. Angle D is congruent to which angle in the other quadrilateral? S. Angle E is going to be congruent to which angle? P. F is going to be congruent to Q, and G is congruent to R. Okay? And the segments match up accordingly as well. So, let's see something that we can solve. Do you think it's going to be easier to find X or Y? Now, okay, the only thing that has a Y in it right here has an X with it as well. Y'all see that? So it's actually going to have, we're actually going to have to find X before we can find Y. Y'all see that? Because this part has an X and a Y. I can't find Y until I know what X is. All right? So look at X. Where I have just an X is this 2X minus 4. Right? That is segment QR. Well, the only segment that I have over here is this 12 feet right here. You see that? Now we have to make sure those are corresponding parts. All right? So does GF, is it the same thing as QR? I'm twisting around funny. Y'all see what I'm saying? You have to make sure the names match up. So GF, which is FG, is that the same segment as Q and R? Yes, because they're corresponding. They're in the same spot in their name. So yes, I can say 2x minus 4 equals 12. Okay, so our statement of congruency said that FG is congruent to QR, so I can set those equal to each other. All right, so how do I solve that for x? Add 4. So 2x equals 16, divide by 2, and x equals what? 8. So anywhere I see an x, I can put an 8. So this 6y plus x, I can call that 6y plus 8. Right? Now I can use that to solve for y. And that's the measure of angle Q. Now what angle is angle Q congruent to? Here's Q. What letter in that quadrilateral is in that same position? F. And what's F? 68 degrees. Y'all see what I'm doing here? Y'all see what I'm doing here? Okay, so if Q is 6y plus 8, Q is in the same spot as F, so I look for F, which is 68 degrees. So I can set 6y plus 8 equal to 68. Does that make sense? 6y plus 8 equals 68. Now how do I solve for y? Subtract 8 on each side. So 6y equals 60, divide by 6, and y equals 10. So any questions about how we did that? Not bad, is it? Y'all try this one. If you can't read this or figure it out from my screen because my drawing is terrible, it's on page 226. Okay? It's at the bottom of the page, I think, on page 226. Okay, number 1 says identify all congruent corresponding parts. So that tells me all the angles are congruent and all the sides that are congruent. And you're going to use this name or this congruency statement to do that. You don't even need the pictures. Y'all see that on number 1? Tell me all the angles and all the sides that are congruent. And number 2, find x and then the measure of angle h. All right, it says to identify all the congruent corresponding parts. So angle A is congruent to what angle? Angle C. Angle B is congruent to what angle? D. Angle G is congruent to, and angle H is congruent to. All you had to do is look at the names and match them up to the one that's in the right spot, the same spot, correct? Let's do the same thing with segments. We got corresponding angles and we also have corresponding sides. So first one, AB is congruent to what segment? CD. BG is congruent to what segment? DE. DH is congruent to what one? EF. And then first and last, AA is congruent to CF. Y'all get those for number one? Now remember, quadrilaterals have 4 angles and 4 sides, so corresponding parts need 4 angles and 4 sides. 4 sets of angles and 4 sets of sides. Got it? Y'all get those? All right, now first I want to find find x on number 2. Well, I see an x right here on this 4x plus 5, which is what angle? Angle H. Now looking at my names, angle H corresponds with which angle? Angle F. Do I know the measure of angle F? 105 degrees. So how am I going to solve for x? 4x plus 5 equals 105. So how do I solve that for x? Subtract 5 everywhere. 4x equals 100, divide by 4, and x equals 25. Now what's the measure of angle H? Now do I even have to solve for x to do that? No, I can check it. 4 times 25 is 100, plus 5 is 105. But I already know that it equals a measure of angle F, right? So the measure of angle H equals the measure of angle F, which is 105 degrees. So raise your hand if you got 25 and 105 for number 2. Any questions? All right, the last thing I want to talk to you about in this section is actually on your theorem sheet. So you can mark it. It's the third angles theorem. It's about right there. The third angles theorem. On front still. The third angles theorem says if 2 angles in one triangle are congruent to 2 angles in another triangle, then the third angles are also congruent. So if you know that 2 angles are congruent in a triangle, then you know all angle measures have to equal what in a triangle? 180. So if I'm subtracting that sum from 180, that would have to be the same amount, right? So that's where that theorem comes from. All right. Just right below that, we've talked about reflexive, symmetric, and transitive property before, so let me just go ahead and mention those. They're right there in the middle of your handout. The reflexive property of a triangle is any triangle is congruent to itself. Remember, reflexive means you're congruent to yourself, right? Like a reflection in a mirror. Symmetric property, if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to ABC. Remember, symmetric means you can swap the order, right? And then you have triangle. If 2 triangles are congruent to the same triangle, then they're congruent to each other. So their example they give you is triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then triangle ABC and triangle JKL must be congruent to each other. And that's transitive. 2 things are congruent to the same thing, then they're congruent to each other. Yep. So we have the same properties we had for a lot of other things. We have those for triangles as well. All right? Well, that is technically all of section 4.2. We're going to go ahead and do section 4.3 because we're awesome. All right. So write down the title, but you do not have to write down the side postulate because it's on your handout. So we're going to actually do some proofs about congruent triangles using side. You did not prove anything. Proofs have statements and reasons. We just learned what corresponding parts were, basically. So, side is a little bit closer to the bottom. It says it's postulate 19 on your handout. It says if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So if we have each and every side is congruent to a side in another triangle, then I can say those triangles are congruent. Now remember, we show congruent sides by the tick marks, right? Sides that have the same amount of tick marks are, the same measure as the other one that matches it on the other triangle. So let's just let's go around our tick marks. So segment AB is congruent to which segment? RS. And segment BC is congruent to what segment? ST. And segment AC is congruent to which segment? RT or TR. Same thing. And I forgot my segment line. So if I wanted to write a congruency statement about these two triangles, remember segments have to line up with each other. So I'm just going to skip a space. So I said segment AB is congruent to which one? RS. Now we got to make sure they line up. Y'all, this is important. Being able to write these congruency statements is like one of the most important things this chapter. I think, are they not the same one on your thing? No, they're actually not. They're written in a different order. They're oriented different, but they're the same letters. All right. So segment BC is congruent to what? ST. And then check, is AC congruent to RT? So make sure when you're finished that all three sides are actually congruent to the right one. Does that make sense? So how you write the name of this congruency statement is important. Okay, it's got to be set up to where all angles are equal and all segments are equal. Okay. Open your book to page 234. We're going to do this real quick and then we're going to jump into proofs. Y'all going to have to open your book and follow along with me because I'm not drawing those three pictures. You're going to have to look. So the bottom of the page where it says guided practice on page 234, there's three problems. Just waiting on us all to get there. All right. So number one says triangle DFG is congruent to triangle HJK. Decide whether the congruent statement is true. Explain your reasoning. So on number one, if it says triangle, I'm going to write what it said. DFG. I got an F. Is congruent to triangle HJK. So that means the segments have to match up according to the picture. So on the picture, does it show that segment DF is congruent to segment HJ? Yes. Does it show that FG is congruent to JK? Do they have the same amount of tick marks? And does it show that DG is congruent to HK? Yes. So this one is a yes. The congruent statement is true. Does that make sense? The reason is because of side. Yeah, because all sides are congruent. No, not because it looks the same. You're seeing if the statement matches the picture. That's what it means by the congruency statement. They got to make sure that the letters match up so that corresponding sides match the corresponding sides in the picture. The names matter. You can't just throw 3 letters up there in any order you want to. You have to write it to where this segment matches this segment matches this segment, and this one matches this one. Yes, as long as they. So it doesn't matter which way they go. As long as it lines up to where corresponding angles and corresponding sides are in the same pattern. But that is a very good question. So look at 2. Number 2 says triangle ACB is congruent to triangle CAD. Now look at your picture. Now they didn't give you tick marks this time. They gave you measures. Y'all see that? Right? And we know that equal measures means congruence. Okay? So look at the picture. Is segment AC congruent to CA? Well, that's the same thing, isn't it? Right? Right? They're the same segment. So obviously it's congruent to itself. All right, the next one is CB congruent to AD. Yeah, because they're both what measure? 7. But is AB congruent to CD? No. Right? Because one of them's 3, one of them's 4, I believe. Right? So is that congruency statement true? No, it's not. Does that make sense? All right, the next one says triangle QPT is congruent to triangle RST. All right, match it up. Does it show that QP is congruent to RS? Does it? They have the same tick marks? Does PT match up with ST? And does QT match up with RT? Yes. So this would be yes, and the reason would be because of side, side, side. Corresponding parts of congruent triangles are congruent. Side, side, side. All right, now we get to do proofs. These are so easy. So again, you just have to make sure. That your segments that are congruent match segments that are congruent, angles that are congruent match angles. Now we're doing side, side, side today. So next week we'll focus more on the angles. So we're mainly just focusing on the segments today, since this is the side, side, side lesson. Draw the picture. This proof is kind of impossible without the picture. Put the right letters in the right spot and all that good stuff. All right, so we're actually proving something. So we're going to need our statements and reasons tables. Right? Last we did it for parallel lines, and we kind of had a weird week last week. We did see a few of them on our Chapter 3 test. Do y'all remember what we used for our first statements? The givens, right? And again, you can put the givens all on one line, or you can make them separate. Sometimes books and worksheets like to have 2 givens. I kind of do them all at once. If I can erase instead of scribble. KM is congruent to NM. And y'all, if they don't mark those congruent on your picture, mark it on your picture. Y'all, pictures are important in geometry. So KL is congruent to NL, so I need to make sure I put the same number of tick marks on those 2. And also KM is congruent to NM. So make sure you put the same number of tick marks on those. Do what? How have I already proved it? I haven't. I've only got 2 sides congruent. To show that the triangles are congruent to each other, I need all 3 sides. So what property says something is congruent to itself? Reflexive, right? So I cannot just say, yeah, they're congruent triangles. I have to show that third side congruent to itself. Right? Y'all see that? They share this side right here. They both have LM. Right? Well, one way it might be LM, the other one ML, okay? But they both have a LM, okay? But you have got to say that LM is congruent to LM. Does that make sense? To use side, 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 you have to show that all three sides are congruent. So that's my step 2. LM, that looks like an angle. LM is congruent to LM. That's supposed to look like an L, not an angle. LM. What reason did we say? Reflective property. Now do I have all three sides congruent? So then I say triangle. Now make sure you have the letters in the right order. KLM is congruent to triangle NLM because of the side, side, side postulate. And you can abbreviate that SSS. Side, side, side on this section, yes, but not for the rest of them. Because this is the only triangle theorems we know right now. What's actually postulate. But next week we'll learn about side, angle, side, but not angle, side, because there's no such thing. Because we don't want to abbreviate that on our paper because that's not nice. Remember? But there really is no such thing as angle, side. I'll talk more about that next week. Oh, some of y'all just now getting. There really is no ASS. There's not. There's no angle, side. We'll have angle, side. No, that's the same thing. Ah. Okay, we'll have side, angle, angle, side, but no angle, side. Or side, angle. Yeah, y'all remember that, right? Then we'll also have hypotenuse leg. When you have a right triangle, you have a hypotenuse leg. We'll talk about it next week, y'all. It's going to get deep. Okay, now this one, see, there's just a preview. Okay, y'all are all excited about next week. How about we're not going to have cuss words on our paper. All right, this one didn't give you a given in words, right? But they did give you a picture. Yes, and that picture has tick marks on it, which means what? Congruent segments. Right? Right? A, B, C, D. And this says triangle ABD is congruent to CDB. There's not an angle O. It's okay. So this looks like a quadrilateral that has been divided into two triangles. Y'all see that? And I want to prove that those two triangles are congruent to each other. So if I'm proving, I need statements and reasons in a table, okay? Somebody tell me something that is given to me. Something that's congruent that is given to me. Okay, DC is congruent to AB. You can reverse the order on those. And AD is congruent to BC. And those are given. They didn't tell me words, they told me the picture, so I'm going to put parentheses in the picture. So that way if you're looking at your notes, you'll know. Okay? So what else can I say? I need how many sides to say they're congruent? 3. I can say that DB is congruent to itself, right? And they both have DB in them, right? They reverse the order, but they're the same thing, right? So, can say that. DB is congruent to itself because of what property? Now, do I have all three sides congruent to three sides in both triangles? Yes. So I can say triangle ABD is congruent to triangle CDB because of what postulate? That side. Hey, we have not talked about angles yet. Save it for Tuesday. One more, and then we're done, I promise. Can y'all do one more? One. Mississippi. We're good. We just have one more to go. Okay. 37 problems. Exactly. That wouldn't be much at all, would it? I'm going to go add to this then. 37. Caleb, 37. All proofs. Just kidding. Okay. This one actually is one out of the problem set of the book. Okay? This one is out of the book. It's number 26. We're going to do it together. All right? Slightly different. We're actually not using the reflexive property on this one. Draw the picture, though. And instead of writing it out like this, if you just want to start with statements and reasons, that's fine. Right? Because we know our given is our given. You can just write prove that and then start with statements and reasons. Would that be okay? And draw your picture. There's actually 3 things given to me. Right? No. We're not using the reflexive property. All right, let me write down my givens. First of all, AE is congruent to CE. And they already marked that one, didn't they? So go back, anytime I give you something, make sure it's also marked on the picture. And if it's not, you can mark it. Okay? AB is congruent to DC or CD. That one's marked. And then they tell you that E is the midpoint of BD. And all of that is given. And like I said, if you're working this on a worksheet or a test or something, they might actually even have 3 totally separate givens. Okay, so watch for that. I like to put all my givens together just to save paper and space. But sometimes worksheets and tests and stuff might have this a blank, this a blank, and this a blank in the beginning. Or they might hold this one till like later on. They're crazy. I like to save space. All right. So it told me 2 of the sides are congruent, right? But they gave me information about the third side, right? It says E is the midpoint of BD. So here's E. It's the midpoint of segment BD. What does that mean? That means that E is equidistant from both edges, right? What does equidistant mean? Same distance, right? So that means the length of BE is the same as the length of ED, right? Meaning those two segments are congruent. So I can say BE is congruent to segment ED, and that's because of what, do you think? The definition of a midpoint. Okay? They told me that it was a midpoint. So because of a definition of a midpoint, I can say that, I'm sorry, my picture is way up there. I can say those two segments are equal to each other, right? Because E being the midpoint of that big segment tells me that it breaks that into the two congruent parts. Does that make sense? So my reason is because of the definition of a midpoint. Now, do I have all three sides congruent? Yes. So last I can say triangle EAB is congruent. Oh, that's crazy looking congruent sign. And that's a crazy looking triangle. Triangle ABCD because of side. Any questions? So it's not that bad. Our first triangle proofs were not terrible, right? All right, so that's actually the end of section 4.3. Have a good day.